Lesson 36. We're going to go over Lesson 36, which is Unit 6-7 in the pre-calculus book. It's graphing other trigonometric functions, and the other trigonometric functions are tangent, cosecant, and secant. I'm probably not going to graph cotangent. We could and just kind of talk about it. We graphed in the introduction to Lesson 36 the tangent wave, but we're going to do that again just to kind of lock in that information. We have the memory work from the unit circle that we needed to memorize. We've got 30, 60, 30, 45, 60, 90, 180, 270, and 360, and we have those in terms of pi. In yellow, remember, that's our quadrantal angles, and we use those to graph sine, cosine, and tangent. We didn't use the other values because a lot of those are square root things and they're hard to pinpoint, and we can get a general graph without them. If you wanted to put those in, you could, and it would give us a little bit better indication of where things are going, although it's not necessary to graph a general curve. Now, we're graphing by building tables. That's what we've done ever since Algebra 1. You'd build an XY table, set of ordered pairs, plot those ordered pairs. We've been doing that the whole time. We've just been pulling those numbers out of our head because we were supposed to have this table memorized. We've got it here where you can see it with your eyes, and maybe that'll do us a little bit better. If we wanted to graph the tangent wave, what we notice is that if you look at this line and we think about tangent, that's off a little already. If you think about that, then remember we had a vertical asymptote everywhere there was an undefined on the tangent wave, right? And did you notice how far apart those were? This first one was at pi over 2. The second one was at 3 pi over 2. They're pi apart. So you may have noticed that on the tangent wave in the review that the asymptotes are pi apart. And in the middle of that was a place where it hit the x-axis, so we had a 0 right smack dab in between the asymptotes. And so then what we did is we said it's going to snug up against that asymptote, go through the 0, and then snug up against the other asymptote. And so that's what's happening on a tangent wave, okay? Now that happens every pi, but the very first 0 was where? It was at the origin. So when we go to graph the tangent wave, the very first 0 is at the origin, which means the very first asymptote is pi over 2 from that. And the next one is going to be pi to the right, which means that the other half of my tangent curve is really going over to the left. So if we're going to graph the basic tangent wave, we're really going to be on either side of the origin, okay? Either side of the y-axis. And so here's what we're doing. We're starting with this one, and we're saying, okay, it's undefined here, and it's 0 right here, and the next time that I'm going to have an asymptote on the other side of that 0 is at negative pi over 2. Negative pi over 2. So if I'm going to graph a basic tangent wave, I'm going to snug up against the asymptote, turn to my intercept, and snug up against the other asymptote. It really doesn't hit the asymptote. It ever so closely approaches that. So there's the basic tangent wave. Now that repeats itself. If we went another pi to the right, that would put us at 3 pi over 2. That's where the next asymptote is. Sorry about the smartboard doing everything crooked. And in the middle of that would be another 0. and then we would have a repeat of that tangent wave. So what is the period for the tangent wave? It's pi. That first pi actually happens from negative pi over 2 to positive pi over 2, but it's still a period of pi, you see. Where sine and cosine began their first curve at the y-axis, the tangent really begins its first replication, if you want to call it that. I got to call it something, at negative pi over 2. And it finishes its first replication, or its first curve, at positive pi over 2. Any questions on the tangent wave? Okay. Let's look at the secant and cosecant waves. Now, remember that cosecant is the reciprocal of what? Cosecant is reciprocal of sine. So we should be able to take those sine values and reciprocate and get the cosine values, right? Okay, so here we go. What is the reciprocal of 0? Undefined. The reciprocal of 0 is undefined. So cosecant 0 is undefined. Let me show you why. If you take 0 divided by some number, what's the answer? 0. If you take the reciprocal of some number divided by 0 divided by some number, you get some number divided by 0. What's anything divided by 0? Undefined. So the reciprocal of 0 is undefined, and the reciprocal of undefined is 0. Okay? All right, understand that? I'm going to leave that there for just a second. Now, then we get to the 1/2. What is the reciprocal of 1/2? 2 over 1. We have square root 2 over 2. The reciprocal of that is 2 over square root 2, but you have to rationalize. And so we get square root 2. Let's see how we got that. Better remember how to rationalize. All right. And then we're going to have pi over 3 with square root 3 over 2. The reciprocal of that is 2 over square root 3. Again, we rationalize. And we get 2 square root 3 over 3. We're writing these as radicals in simplest form. It's kind of messy, doesn't it? Okay. And then the next one was 1. That's kind of nice. Reciprocal of 1 is 1. Back to 0. Reciprocal of 0, undefined. Reciprocal of negative 1, negative 1. Reciprocal of 0, undefined. Now remember, we're really mainly concerned about the yellow ones, our quadrantal angles, right? We're really worried about our quadrantal angles. Now, to get a full period for cosecant, we still need the same amount of room that we had for sine, right? We're still going to need 2 pi before we get a full replication, okay? Is everybody done with all this red scribble down here? All right, so let's draw us a little grid then. I could just make that one bigger. I'll just draw one here so we can see the whole thing. Now, my period is still 2 pi, same as it was for sine. And we're going to cut it in half pi, and we're going to cut that in half pi over 2, and we're going to cut that in half pi over 3 pi over 2, excuse me. So we still have the same normal period. every time we have undefined, what do we have? A vertical asymptote. So there's going to be an asymptote at 0. There's going to be an asymptote at pi. There's going to be an asymptote at 2 pi. Understand that? So everywhere we had an undefined up here, it turned into an asymptote in the graph. Now let's look what's happening in between there. We're looking at the yellow, right? The quadrantal stuff. At pi over 2, where are we at? At pi over 2, I'll do this in green. At pi over 2, we're at positive 1. Let's call this positive 1, and let's call that negative 1. At pi over 2, we're at positive 1. At 3 pi over 2, we're at negative 1. It's right in the middle. It's not on the line. Now, we really don't know what's going on with this thing. So we really ought to graph some of those crazy ones, right? So let's just do one of those crazy ones right quick. At pi over 6, we had what? 2. Now, where's pi over 6? Well, if we took that and divided into 3 sections, and this and divided into 3 sections, one of those 3 sections would be a sixth, right? We took pi and divided into 6 sections. And this is a 2, and so pi over 6 would go to 2. That means there's a point way up there somewhere. Do I agree? Now, let's scoot over just a little bit. Let's say we had pi over 4. Now, where's pi over 4? Well, pi over 4 is still before pi. What about, we got pi over 2. We could chunk something else in there. I'm not going to do any more things. I just kind of want you to see. We could plug some points in, and we could get some data. And if we plugged in some points and got more data, we would find out that it's doing that. And so it's going to hug the asymptote, come down and turn at that point and come up. We could make up more points than is in this table, and we'd figure that out. Okay? And then what we're going to find if we were to make some more points and plot, we would find that over here it does that. Ooh, that's weird. It moved it on me. It wasn't supposed to move. There we go. Okay? That's kind of ugly. Let's see if I can do it again. We've got 3 pi over 2. We had a point at negative 1, and my curve is hugging the asymptotes and turning. Now, what did the sine wave look like? It looked like this, didn't it? Those are supposed to bump. That's the same point. I make it kind of fat. So you can see that the cosecant wave looks like the sine wave that got split in half, and that first curve flipped up and the second curve flipped down. Are you kind of seeing that? It reciprocated, kind of, sort of. Okay, you can get the idea of kind of what's happening. So everywhere the sine would make another hump up, cosecant would do that. And every time it would make another hump down, cosecant would do that. Okay? As they approach those asymptotes. All right, any questions on the cosecant wave? All right. Well, let's look at the secant wave. Secant is reciprocal of cosine. Secant is reciprocal of cosine. So we'll reciprocate everything. I'll do this one in black. So we're going to be looking at the cosine of 1. Cosine of 1 is, cosine of 0 is 1. Its reciprocal would be 1. So secant 0 is 1. We're not going to memorize secant, cosecant, cotangent. We're going to memorize sine, cosine, tangent, and then reciprocate. That's how we're going to do it. All right? So the cosine of pi over 6 was square root 3 over 2. You reciprocate that, you get 2 over square root 3. You rationalize that, and you get 2 square root 3 over 3, right? So we reciprocated and then rationalized, and we get 2 square root 3 over 3. And then we have square root 2 over 2 for pi over 4. The reciprocal of square root 2 over 2 is 2 over square root 2. We rationalize. We get 2 square root 2 over 2. We reduce and get square root 2. So it's square root 2. Okay? Now, everything we're doing, you're accountable for eventually on a test or something. You're going to have to be able to think through all this stuff and rationalize and all of that. Okay? Pi over 3 was a half. What's the reciprocal of a half? 2. Now it's starting to get easier. The cosine of pi over 2 is 0. What's the reciprocal of 0? Undefined. Negative 1's reciprocal, negative 1. 0's reciprocal, undefined. 1's reciprocal, 1. And so we have our most important memory work for secant, which we really got from cosine. And I'll get rid of this down here. And we will graph. Now, we're still going to go from positive 1 to negative 1 because we're really dealing with the reciprocal of cosine, so the period stays the same and the amplitude stays the same and all of that. And so we're going to have 2 pi, and then pi, and then half pi, and then 3 pi over 2, same as sine and cosine. We're going to put asymptotes where we got undefined. So we have an asymptote at pi over 2. We have another asymptote at 3 pi over 2. Remember, the cosine wave started up and went down and came over and up. Remember, that's the cosine wave. We're graphing the reciprocal of that. It ought to bust apart kind of like sine did, okay? We're going to see that happen. And so at 0, secant was 1. At pi over 2, secant was undefined. At pi, secant was negative 1. At 2 pi, secant is positive 1. And what we're going to see is that it's going to bounce off of that and go towards the next asymptote. It's going to bounce off of that and go towards the next asymptote. And it's going to hug the asymptotes and bounce down. And so secant and cosecant are bouncing off of sine and cosine and following those asymptotes. Okay? Any questions on that? So if we went on out a little bit and we drew that next asymptote, we would obviously have this situation. If we came out here and drew the next asymptote, we would have this situation, and that would just continue to repeat itself. Okay? All right. What's going to happen with cotangent? If you recall, on tangent, we went from pi over 2 to negative pi over 2, and we had that situation. If we do cotangent, it's going to do that situation, okay? Any questions on those? We're not going to do cotangent. You can plot the points and figure that out. Okay? All right, any questions on those? Now, what we want to do is go over the worksheet that looks like the test so we can kind of get an idea of what we're going to be doing with this. And when we first start this, you're going to go, well, why did we do all that graphing? We don't even need it, but we are going to graph eventually. What we're going to do to start with, though, is we're going to use all this information up here in our memory to answer these questions, and we're also going to use the unit circle, and we're not going to forget that they're all positive in quadrant 1, sine is positive in quadrant 2, tangent is positive in quadrant 3, and cosine is positive in quadrant 4, a smart trig class. So we're not going to forget that. Okay? Now, let's look at number 1. Number 1 says the cotangent of 5 pi over 2. Now, what we have to do is figure out what quadrant it's in to figure out its sign, right? So I'm just going to write that down just so you know. We want to know what quadrant. That's very important. And we also need to know the reference angle, right? The reference angle is going to tell us the number, and the quadrant is going to tell us the sign. And there's different ways of thinking through this, but I'm just going to show you. We're going to take out 2 pi's and pi's, right? So I'm going to rethink this as the cotangent, I'm going to rethink this as 1 over the tangent of something, okay? Cotangent is reciprocal of tangent. Now, I haven't memorized cotangent. You haven't memorized cotangent. What we memorized was tangent. So we're going to rethink it as a tangent situation, 1 over tangent something. But we need to get the reference angle, so we need to take out all of the 360s that we can, and then the 180, and then see where we're at, right? Okay, now we're dealing with a divided by 2. So how many pi over 2's is equal to a whole revolution? 2 pi is equal to 4 pi over 2. That's what I was trying to say. How many pi over 2's makes 2 pi the whole way around? 4 pi over 2's. So I'm going to take out 4 pi over 2's. And what I just did is I said, okay, I'm going to take that out right there. I just took out 1 all the way around. Now, what's left when you take 4 pi over 2 out of 5 pi over 2? You're left with 1 pi over 2. Is there another all the way around you can take out? No. Is there a halfway around you can take out? No. When you take that out, you're left with something that's less than 90, right? We want to get an acute angle. We're going to take out all the way around and halfway arounds until we're left with something that's acute. And what we're left with there is pi over 2. Now, pi over 2, if we put that with the all the way around we took out, tells us we're right there, right? This is exactly where we are. That's where we landed. Okay, that means that really what I want is 1 over, that's ugly, I want 1 over tangent pi over 2, right? What is tangent pi over 2? Tangent pi over 2, tangent pi over 2, undefined, I have 1 over undefined. That means I have the reciprocal of undefined. What is the reciprocal of undefined? 0. So the answer is 0. Everybody still, we got that. Now, my reference angle was pi over 2. My quadrant, we wasn't in a quadrant. It was a quadrantal angle. Okay? Everybody understand what we did? Okay? Let's take a look at another one there. Is everybody done with that before I click it? It forgot. Okay, let's look at number 2. Number 2, we have tangent negative 4 pi. Now, we know what tangent is, so we're okay with that. Now, we're going to take out all the way around, right? Now, we could take out 2 all the way around backwards, correct? That means we took out an all the way around backwards once, and all the way around backwards twice. Negative means we're going clockwise. What's left when you take out 2 of all the way around backwards? Nothing. So what's my reference angle? 0. What's the tangent of 0? 0. You understand that? Okay. All right. Number 3. Number 3, we have secant 9 pi over 2. Now, we don't know anything about secant. Oh, excuse me. We don't know anything about secant, but we know that secant is the reciprocal of cosine. And we're going to take out a whole bunch of circles and half circles until we end up with a reference angle, right? And we would be interested in the reference angle in the quadrant. So, pi over 2's. How many pi over 2's makes an all the way around? 2 pi is equal to 4 pi over 2. How many sets of 4 pi over 2 are there in 9 pi over 2? We have 2 sets of 4 pi over 2. That would be 8 pi over 2, which would be 2 all the way arounds. Understand that? So that means I'm saying, okay, we're going to take out a 4 pi over 2 and another 4 pi over 2. We've taken out that much. If we take out 2 sets of 4 pi over 2, that's 8 pi over 2. What's left? Pi over 2. So my reference angle is pi over 2, and it's a quadrantal angle. So I'm going to rethink that as cosine of pi over 2 plus some circles, so I can really think about cosine pi over 2. So I have 1 over, what's the cosine of pi over 2? 0. And 1 divided by 0 is undefined. And so my answer is undefined. Any questions on the first 3? So we have to really still know our chart up there, right, from memory. And we've got to understand that we're taking out all the way around, and we've got to know something about fractions to be able to convert 2 pi to 4 pi over 2 and take those out. Any questions so far? Okay. Whoa. It's just trying to come with me there. All right. So it says, find the values of theta for which each statement is true. Okay, number 4. Tangent of theta is 0. Now, when is tangent 0? At 0. When is it 0 again? At pi. So if we want the set of all, then when's the first time it happens? 0 plus every time it happens again, which is every time you add a pi. So pi k or pi n, right? We'll put pi n. Everybody understand the pi n? N is an integer. So it happens at 0, and then going around the circle halfway around. as many times as you want to go halfway around. Okay? In other words, the tangent of 0 is 0. The tangent of pi is 0. So it's here, 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 here. I'll stop. All right, you understand that? That's the set of alls, right? 0 plus pi n. Okay. Number, no, that was number, there wasn't a number 4. That was number 5. Number 5. Number 5. Okay, number 6. Number 6, we have cosecant theta equal negative 1. Now, what would you really be thinking? You would really be thinking, when is 1 over sine equal to negative 1? Which is really, when is sine equal to negative 1, right? If we're saying when is cosecant theta negative 1, we're thinking, well, cosecant is reciprocal of sine. And if I want the reciprocal of sine to be negative 1, that means I need sine to be negative 1. So we're thinking, well, where is sine negative 1? Well, the sine is negative 1 at 3 pi over 2. Now, when's that going to happen again? The next time you get there again. You got to go all the way around, right? Because at pi over 2, it's 1. You see, sine is 1 here and negative 1 there. The first time sine is negative 1 is at 3 pi over 2. But it's going to be that again after you go all the way around, which is 2 pi, as many times as you want to go all the way around. Okay? That makes sense? Okay? Whoa. It's very touchy today. All right. Number 7. Cotangent theta, I always make a cursive T because it looks like a plus sign if I don't, is equal to 1. Well, we don't know about cotangent, but we know about tangent. It's reciprocal. So we're really going to kind of be thinking, when is the reciprocal of tangent equal to 1, which really means, when is tangent theta equal to 1? So all that went through our head, right? If cotangent theta is 1, that means that the reciprocal of tangent theta is 1. And if the reciprocal of tangent theta is 1, that means that tangent theta must have been 1. And we're thinking, well, then when is the first time that tangent theta is 1? Tangent theta is going to be 1 at pi over 4. And remember, they're all positive here, right? Where's tangent positive again? Quadrant 3. And so when is it going to become, when we think about a reference angle of 45, or pi over 4, when's it going to happen again? Tangent is going to turn into a positive 1 every halfway around instead of all the way around, you see? It wasn't a quadrantal situation. It was off in the middle over at pi over 4. And tangent's positive in quadrant 1 and 3. So it happens the first time at pi over 4. It happens again when you go halfway around. And you can go halfway around as many times as you want to. Pi over 4 plus pi n. Understand that? You really don't need to try to memorize those problems on the worksheet and hope you're going to get them right on the test. You need to understand them on the worksheet and then think them out on the test. Okay? Any questions there? I think we'll stop there because when I start graphing the cosecant and tangent, it's going to take a little more time than I have left. So we'll have lesson 36 part 2. We've got an introduction, we got part 1, and then we'll have part 2. Appreciate your attention.